These are the video notes for section 8.5, dividing expressions with square roots. We actually did very similar to, for 1, 3, and 4 that I have up here, we kind of did this in section 8.2, so this is kind of a review where we're going to reduce the fraction or divide. So 42y divided by 6y would be 7, and we would keep the radical because we have the radicals here, so this would be root 7 as your final answer. In this example, we're going to divide root 3 into the numerators. So root 3 goes into root 12, that would be root 4, minus root 3 goes into root 45, that would be root 15. And then we can simplify this expression. Root 4 is 2, and then root 15 remains the same. Since we can't combine these, our final answer would be 2 minus root 15. In this example, we're going to divide. So 3 goes into 36 12 times. Y goes into y to the 5th, y to the 4th times, and the radical stays the same. Here we're going to continue to simplify. I'm going to break the 12 into 4 and 3, keep the y to the 4th because it's already a perfect square. I'm going to simplify square root of 4, which is 2, square root of y to the 4th, which is y squared, and root 3 I'm going to keep the same. So my final answer is 2y squared root 3. In this example, I'm going to simplify, again, divide into it. 4 goes into 48 12 times. A to the 4th and a to the 4th divide out. B to the 7th and b to the 7th divide out. So I have square root of 12, which I can break up into 4 and 3. And my final answer is 2 root 3. In the last part of the notes for 8.5, we're going to rationalize the denominator. We rationalize the denominator when the denominator is a radical. So for example, 1 over root 3, we would have to rationalize the denominator. We do so by multiplying the fraction by 1 using the denominator over itself. So I'm going to multiply this expression by 1 using the denominator over itself. Because root 3 over root 3 is 1, and we can multiply any expression by 1 without changing its value. So step 2, we're going to simplify if possible. 1 times root 3 is root 3. Root 3 times root 3 is root 9. And now I'm going to simplify. Root 3 stays the same. Square root of 9 is 3. So if you see now, 1 over root 3 becomes root 3 over 3, and the radical has disappeared from the denominator, and that is what we want. So in the next example, we're going to rationalize the denominator. I'm going to multiply by root 3 over root 3. We ignore the 2 when we're multiplying by 1 because 2 is okay to be in the denominator. Our goal is to get rid of this root 3. So I'm going to use that specifically to multiply by 1. Now I'm going to simplify. Negative root 7 times root 3 is negative root 21 over 2 root 9. Now I'm going to simplify negative root 21 over 2 times 3 because the square root of 9 is 3. And then my final answer would be negative root 21 over 6. Now for our last two examples, I wrote it down twice because there's two ways that you can go about this. So we're going to do the traditional way first. I'm going to rationalize the denominator by multiplying by root 20 over root 20, which is 4 root 20 over root 400. I'm going to simplify this. Root 20 can be broken down into root 4 and root 5. And square root of 400 is already a perfect square, so I'm going to keep it the same. Square root of 4 is 2, so I have 4 times 2 times root 5 over. The square root of 400 is 20. So 4 times 2 is 8 root 5 over 20. And then we need to simplify the fraction. 2 goes into both. I have 4 root 5 over 10. And simplify one more time, 2 root 5 over 5. So the other way that we can do this is we can actually simplify first the root 20 to root 4 and root 5, and I'll get 4 over 2 root 5. And then I can rationalize the denominator this way using root 5 over root 5. And this will be 4 root 5 in the numerator, 2 root 25 in the denominator. So I have 4 root 5 over 2 times 5, which is 4 root 5 over 10, which reduces to 2 root 5 over 5. The reason why I like to do it this way is because when you simplify the denominator, you end up working with smaller numbers. Here, you end up with larger numbers. You'll still get the right answer, but it takes a little more time. So if you would like to, you can simplify the radical first and then rationalize later. But it is up to you.